All right. So there have been some problems, some misunderstandings, some issues with Lab 5. Totally get it. So I am meeting here with our friend Chloe, and she has some questions, which just about everyone else in the class probably has. We're going to go over some of the common issues that are going on with Lab 5. And I'm getting this out to you here on Tuesday. So hopefully you have plenty of time to turn it in before I have to do all of the grades on Friday. All right, so right off the bat, let's just start with um, number one here, if it'll let me pull up what I'm looking at. There we go. All right, number one, the townships and ranges. Some of you, actually, most of you did okay on those, um, but there are still some confusions. The townships and ranges specifically have to do with the rows and the columns, not the lines. Okay, townships and ranges are the rows and columns between the lines, not the lines themselves. Okay, so you'll need to identify where the locations of those dots are based on which row and column they're in, just like in an Excel spreadsheet. Okay. Question two, would topographic maps of the moon or Mars need to be updated very often? Why or why not? Um, Let me pose it to you this way. Okay. What does Earth have that the moon and Mars do not?
Well, Earth has obviously water. It has an
Mhm,
atmosphere.
mhm.
Um, I
Do the
think
moon or Mars have either of those?
I don't think so.
Not in enough quantity to matter.
Okay.
What effect on our planet does so much water and atmosphere have?
What effect? I mean, they're definitely constantly moving, changing tectonics.
Boom. Okay. Makes Earth dynamic. What I'm specifically referring to here is the weathering and erosive effect of those aspects of our planet. So, if the moon and Mars do not have enough atmosphere or water to make the constant moving of sediment, the breakdown of material, all of these things, then does the topography change very much?
No.
No, it does not.
Okay.
There we go. Okay, so it's one of those logic puzzles that we do in class sometimes. Yeah, it doesn't change that much at all. Really, the only time it ever does is when something hits it, right? Which is not that common anymore. Um, there's a meteorite that might be hitting the moon here in the next couple of years. We're watching it very closely because if it does, it could raise some problems with putting debris in Earth's atmosphere and stuff like that, destroying satellites and everything. It's a couple hundred meters long. It'll make a new crater if it does hit the moon, unless we deflect it. They're still deciding whether or not it's worth the risk or whatever. They're still doing that math, but that's really the only occasion anymore when there's a meaningful change in the topography that we would need to consistently update. Okay,
Okay.
good. Okay, question number three. Find the highest elevation of the one topographic map you chose. Most of you only did one. A few people, even though I bolded it and highlighted it and I had it in the instructions, did both maps. Twice as much work. You didn't need to do that. Okay, you only needed to pick one map. So we're going to look at Hoquiam because that's the map that Chloe chose. So we're going to look at this. Let's see, I'm going to make it a little bigger here. Chloe, can you see as I'm zooming in here?
Yes.
Okay, great. So how do we find elevation? That's what the little red squiggly lines are. Those are contour intervals, okay? They represent a change in elevation, all right? So for the distance between this line and that line, there is some change in elevation there, all right? So your goal here for this question is to find where the highest elevation is, and that's what your contour lines are going to help with. Now, my advice here for doing this one is to find the contour lines with the largest numbers. See, there's 800, here's 600. So clearly going from up here to down here, we are losing elevation, right? We're going to look for the largest, the highest point on our map, all right? So when you follow the higher elevations, see, here's 1,000, there's 1,000. Let's keep looking for bigger numbers. There's our 1,000 again. Okay. There's 3,000. Okay, we're going to keep looking. There's 3,000 again. 3,000 up there. Okay. Oh, look, here's 4,000. Okay, so here we've wandered our way by following the trend of increasing elevation all the way up to this mountain. Can you see what this mountain is called?
The Mount St. Helens.
Yeah, it's Mount St. Helens. We talked about that, didn't we?
Mm-hmm.
So, Mount St. Helens, you can kind of see all these concentric rings piling up onto it. Why? Because it's a volcano. Volcanoes form cones, and so the elevation changes are going to form concentric rings around it. You can see the glaciers on there and everything. And right here, these big bold numbers, 9677, when you see those tell you the highest elevation of a given peak. Okay, so for right here, Goat Mountain, 4,965. There's a peak right here, doesn't have a name associated with it, but it's 4,537, right? So on and so forth. So as you follow the trends of those contour intervals, you're going to look for where the highest black number is. Okay, so 4,000, we get all the way up over here. I don't see anything higher than 4,000. Okay, this must be where my largest area is. Boom, there's my highest peak. Okay, now it just so happens that this map was made in 1974. Do you remember what year Mount St. Helens erupted?
The 19, was it 83, I think?
Oh,
Or
you're so close. It was 1980. Great.
okay.
Totally put you on the spot there. Something we talked about a long while ago, but you did great. Okay. 1980. So this map was made 4 years before or 6 years before it erupted. And so
Mm-hmm.
what we're looking at is the complete Mount St. Helens here before it erupted. Remember, we lost 400 meters of material off the top. So it's actually significantly shorter than this now. But this is the map you have. And so that's the number that you would give me, even though it is not currently realistic. Okay. So good. All right. So now the next step is to find the lowest elevation, right?
Mm-hmm.
Now, this is something that I talked about in class in that recording when I was giving instructions for this lab. Elevation, people tend to think of elevation as, okay, how far above sea level am I? That's because it's the most relevant to us. Above sea level is the most relevant number for us because that's where we live and breathe, and that's where we take all of our lives are spent up here, right? However, that is not the full meaning of elevation. Elevation is relation to sea level, not just above sea level. There is also such a thing as below sea level. And so when we're trying to find the lowest point, the first thing you need to do is see, okay, do I have ocean on my map? If I have
Mm-hmm.
ocean on my map, how deep does that ocean get? Okay. So look, here we've got, this is the Pacific Ocean right here. Okay. So we're going to be looking for how deep the Pacific Ocean gets on this map. So we're looking for the furthest out contour line. Now in the ocean, contour lines are black instead of red. And there was a very special point that I made, both in the lecture and on the assignment here, where I pointed out that because the ocean is international territory, you use the metric system to measure. Okay. So these lines do not represent changes in feet, they represent changes in meters. So that's our 36-meter mark and our 60-meter mark. Now, what that's saying is not 60 meters above sea level. That's saying 60 meters below sea level. What designation do we give numbers below zero? What value do they have?
Negative.
Negative. Okay. So as for all intents and purposes, this is negative 60 meters. Okay.
Okay.
If we're treating these as positive numbers, we have to treat those as negative numbers because they are below our zero line. Okay. So that would be your lowest point, right? Because here's 60. Let's see if we can find anything greater than 60. There's our 60 again. 36, 36, 36. Nope, that 60 looks like the deepest that we can measure. And so 60 meters below sea level is going to be your lowest elevation. Okay.
All right. Okay. Yes, sir.
Okay, great. What is
And
the next?
it would be negative 60, right?
You can write it either way. Either 60 meters below sea level, you can spell it out, or negative 60 meters, yes. Now, it's okay to leave that one in meters.
All right. And then the next one was the subtracting.
Yeah, okay.
Those
What's
two.
the next question? What's the difference between those, right?
Mm-hmm.
Okay, so how do we find the difference between two numbers?
Well, you subtract them.
Yes. What happens when you try subtracting a negative number, though?
It turns into, well, you would add it together, right?
Yes, the two. Yes. So minus a negative number, the two negatives, you can think of them as canceling out and make a plus. So your big number plus your negative number, except it's not negative anymore for this pin for this instance. You're finding the absolute value of the difference here. Okay. So, but first we have to convert 60 meters into feet. So do you have that conversion that I gave on the assignment?
So 1 meter is 3.28 feet.
Okay, so we would multiply 60 meters by 3.28 to get the number of feet.
So 196.8.
Right. And then what do we do with that?
That's where you would you subtract them, I think?
Because we're getting
Add.
the absolute value of the difference here. Okay.
So it would
So you're
be
adding that.
9. Oh, I'm sorry, what?
You would be adding your high point
Uh-huh.
to the low point because we're
Okay.
finding the difference between them. Okay.
Okay. So yeah, so I would do 9677 plus 196.8.
Yeah.
Okay. Thank you very much.
So let me put it in another, and let me give you another example here. Okay.
Mhm.
Um, let's say that I'm holding my hand above a half-filled bathtub. It's 2 feet above the level of the water. The distance between my hand and the water is 2 feet. Let's say there's another foot of distance between the water level and the bottom of my bathtub. Okay.
Mm.
But the distance between my hand and the bottom of the bathtub is 3 feet. I add this distance to that distance to get the whole distance. Does that make sense?
Okay. Yes.
Great. So what number did you come up with?
So 9,873.8.
Great. You can round that if you want. Okay. Fantastic. Okay. So the next question. Identify the largest non-ocean, non-river body of water on the topographic map you chose using UTM format. Okay.
Okay.
So there's some confusion, it would appear, as to what UTM is and the difference between UTM and township and range. All right. Township and range separates the world into those columns, which are ranges, and rows, which are townships. That is the first grid system that I taught you, but was only going to be used for that first question. Everywhere that I say use UTM, you need to be using UTM format, which you see here. Excuse me. This is where we get our UTM numbers. This line right here on our map. Okay. And then this line right here on our map, and this line right here on our map, and this line right here on our map. Those are designation points between our columns. That's a column. That's a column. That's a column. That's a column. Okay. And they have these numbers here at the bottom of each one. In this case, 430,000 meters east. This is the 430,000 meter east line, just like we had range designations for township and range, but we're not doing township and range anymore. We're doing UTM. 430,000 meters east, 440,000 meters east, 450,000 meters east, 460,000 meters east, right? They shorten it to just the whole numbers. They remove the zeros to save space on the map, okay? Now for our rows, this line right here represents 5,100,000 meters north. This one, 5,110,000 meters north. This one, 5,120,000 meters north. And that's the designation for our rows. So you have the grid system concept, right? You're just using the
Mhm.
wrong grid system to tell me. You following along?
Yes.
Great. So you're going to use those numbers to give me, and again, just like with township and range, just like with an Excel spreadsheet, you're giving me two numbers, one for the column, one for the row. But it has to go by this UTM format system, not township and range, because we're not using township and range for this question. And it's the same thing for the next question. Where is the town that I ask you to find? For that one, you'll have to find the town first, obviously, right? All of the towns are designated in yellow. Okay, so there's yellow, yellow, yellow. Okay, there's yellow, there's yellow. Okay, we're looking further. There's some yellow, there's yellow, there's yellow. Okay, eventually you're going to find the town that I asked you about. Okay, which I
Mhm.
think on this one was Eatonville, right?
Yeah.
Okay, so after you find Eatonville, you're going to tell me which box it's in. All right,
Okay.
which coincidentally is right there.
Yeah.
Okay, so there's Eatonville. What is this box that it sits in? Give me those two numbers. There needs to be that easting number and that north number based on the row and column it resides in. Okay.
Okay. I think.
Okay.
Let's
Where are you
see.
confused at all? Because this is the time to address it.
So I don't know. Well, okay. Would it be the 519 number?
For the Eatonville question,
Yes.
okay, let's come up here. Okay, so it's conveniently located pretty close to the top. All right, so
Mhm.
you're looking at the rows here. Okay, so this is the line for 5,190,000 meters north. There's the 5,200,000 meters north. It is inside of the 5,190,000 line. Everywhere along this row, every single location inside of this row is 5,190,000 meters and something meters north until you reach that line at which it becomes 5,200,000 meters north. So yes, it is sitting inside of that row. So yeah, telling me 5,190,000 meters north is one of the numbers that you need to give me. What's the other number?
It would be, sorry, I have it pulled up on another tab.
Yeah, no
Um,
worries.
one? No. Okay. It would be the 55, which I guess that's 5,500.
Exactly. 5,500. No, not 5,500. 550,000
Oh, okay. Yeah.
should be. Let's look at that number again. Right there. Yep. So if that's 430,000, then by the time we get all the way over here, we're looking at 550,000. Okay. So
Okay.
550,000 meters east, that's the second number. And if you give me those two numbers, then you have given me the UTM location for that town. Now you just need to do the same thing for the previous question of the largest non-ocean, non-ocean, non-river body of water. Just do the same
Mhm. Okay. So for that one, wait, 514, 5. So it's actually kind of, if I think it's the right one, Davison Lake.
Most
That's
people do think,
between, yeah,
yep,
if
Davison
it is
Lake,
that
absolutely
one.
appropriate to choose this one. It goes over multiple squares, doesn't it?
Yeah.
Pick one.
Yes, sir.
If you give
Okay.
me a location and I can track it to Davison Lake, then you
Uh-huh.
succeeded. That's the point.
Oh, okay. Okay,
So
that
it
makes sense.
covers this one, this one. It's like one of those AI tests. It's like click all the squares that contain Davison Lake, right? But you only have
Yeah.
to give me one. Most people, they'll go for this one because most of Davison Lake is inside of that box. But it really
Mhm.
doesn't matter which one of these four you give me, as long as it takes me
Okay.
to Davison Lake.
Okay. Yes, sir. All right. Well,
And then I
right.
believe there is
One
another
more
question.
question.
How do you
Yes.
know whether slopes are steep or gentle by looking at a topographic map? Oh, that's a typo. It should say by looking at a topographic map. I will fix that.
Well, I got that one right. So, the
Yes,
closer together the contours are, the steeper the mountains are. If the lines are farther apart, the slopes are gentle.
absolutely. The closer they are, the closer those contour lines are, the faster elevation is changing over horizontal distance, right? So it's the difference between what's the elevation change from here to here over this distance, and what's the difference, what's the change from here to here over this distance, right? Much faster elevation change over a shorter horizontal distance if you were to think of this as a triangle, right?
Mhm.
Perfect. All right, any
Yeah.
last questions for me?
Nope.
Did this answer everything you needed?
Yes. Yes, that was way more helpful. So,
Great. I'm glad. I'm glad. I hope this
thank you
is
very
helpful to
much.
everyone. We still have a few days left in the semester. If any of you do still need help like this, please feel free to reach out to me, and I will give you all the assistance I can, wherever I am, however I'm feeling. All right.
Yes, sir. Thank you very much. I appreciate it.
Thank you, Chloe. Have a good day.
You too. Bye bye.